Okay, good morning, everyone. Welcome back. Oh, I'm getting an echo from someone. Yeah, that's good. So sorry for the delay. There's a few things to set up there. So, but just before we finished, we looked at setting up a Flask app. Remember, there's quite a lot involved there. So we're basically we're in week 7 at the moment. So we're here. Hopefully you're working on your ethics, or even better, you've already done it, so that you can focus on this. And then we're now working towards our web app, which will take up most of the rest, which will take up the rest of this part of the semester. And first, the part 1 is where we deliver the milestone, which is where you just to make sure you've got everything set up online. So we'll get there, and then the main thing we're working towards is our web app. So it's just a reminder of where we are in the semester. So we've talked before about full stack web apps, where we started with Python, and looked at the web. So we started with Python. We've started to see last time how you can create web pages from Python, but now we're going to start looking. We sort of started on that just to give you the context, but now we're going to start looking at the database. How is it you can get data out into the database? Because that's where things really start to happen, because things can become a lot more dynamic. The small examples we gave have been kind of limited. The assessment we gave for Python, we created lists of tuples, but if you have to create all of them manually, it gets quite long. But instead, we're going to get those lists of tuples from the database. But before you do that, we have to know how to work with the database. So I'm going to show you how these things fit together, how Python and the database fit together in the whole full stack Flask web app environment. But then we're going to focus mostly on here for the rest of today's this part here. How do you get data out of a database? So let's skip past that. So to recap, remember we created our app.py file when we created our Flask environment. So this diagram, you may find it a little bit confusing, but I'll keep repeating it, and as you get more experience, it'll start to make more sense. So we have our app.py file, and you remember we used the @ sign, and above which was the decorator, and that related to a URL. So in this example, /home would run a function which then links to some Jinja templates. So remember, we created the templates which could link back to Python. So the Python function can call a Jinja template. But now we're also adding in the idea of a database, which is where information is stored. So process works through URLs. So a URL comes in through the front door, which is app.py is that front door. And in this case, if we get the home URL, it'll direct through to a HTML page called index.html. And then there'll be some sort of link that's clicked on that page, which comes back round as a URL and comes in through again. And this time maybe it's an order. And so it comes into this function. It renders the order list page for us. And then it goes around again. So on this page, there'll be a URL of some sort that will be clicked or created. And that when the web server detects the URL, it sends us back through to app.py. And maybe this time it's order edit. Actually, no, it's order it's a different, so you can actually go to 2 pages from one function. So we can choose which page we render and so on. It goes around like that. That's the basic feature. And we'll go into what these details are later. But the key thing that I want to talk about here is, so when we come into home, let's say the home, we come in with a URL which is /home that comes into this function, and we need some data on the home page for a drop-down list. We've got a drop-down list maybe of customers, a drop-down of customers. So we need to get the data from the database to populate that drop-down list. So what happens is when we get the at home, it comes into the first function called home, and we need to get the data somehow from the database. So the way we do that is with what's called SQL. So we send, and we're going to look at this shortly, we send what's called a query in SQL, which is structured query language, and we send a request through to the database. And that'll be a specific request using SQL to say what we want to get out. And then that returns some data. Back to our function. So now we have a list of tuples, which has come from the database, which will be our customers, ready for that list. And then our Python sends that data to our, when it renders the template, it sends it to the page. So you remember that we could send, when we rendered the page, we could send a list of tuples through to that page. That page then takes that list of tuples, and in the HTML, hopefully you guys have had a bit of a look at HTML over the break. It creates a loop in Jinja, produces the drop-down list for us. Then when someone selects the drop-down list, they click on it, and maybe they click a button or a link. From here, it sends out a URL, and we come in again. So maybe this time they've selected that they want an order. So they've clicked on the orders link, and this time we want to get orders information from the database. So somewhere in our code, we've said we've asked for all the information, and we now want them. We're now ready for the data from the database. So go around there. So we've got some logic in our function that says if there's no other information coming in from above with our URL, then we want to get some more. We get some data from the database. So we send out SQL. We create the SQL query in Python. Then the database sends the data back, goes through to the page, and goes around with another URL. When we're ready to do an order, an edit an order, we do this one too. So from here we send an SQL query to the server. The server sends some data back as a list of tuples. We then pass that onto the Jinja page, onto the template, which Jinja then does its thing with, and then it comes around again, and so on. So it's just wanting to get you used to the idea that we have a database here, and in our functions, because some of you may be used to writing SQL, you can write SQL on a keyboard, select star from people, and it'll return that table to you. And Python can also create those kind of queries using code to create the query, and it sends it to the database and it sends the data back. So that's the process we're going through here. And I'm going to show you how this works, but we're going to focus mostly here. But just keep in mind that we're going to be getting all of these pieces linking together. It looks quite complicated, but it just gives you an idea of what's going on in this whole process. Okay. So on the Learn page, we come down to the web applications section. Down here, we've got the library demo web app. So this is based on a previous assessment, and it's an example of the kind of, it's a simplified version of what we did for an assessment, but it's an example of the kind of web app that you're going to create. So you can get that from here. That should be a zip file that downloads, and I've already set this up over here. So I've already unzipped the file, and I've got library web app, and you can see it's got the virtual environment and things. So I can, on a PC, the easiest way is to right click on this and go open with code, but I actually already have it open. Yeah. So we've now got this, what is hopefully familiar to you from last time. We have our app.py file, and we have a virtual environment set up, and also the templates. So some of the pages that are going to be used are in there. And then we have our Flask. We're importing the Flask module and some of the other modules. One other thing that we've set up here, which we'll go through in more detail later, is the MySQL connector. So in this diagram, we said how we could send SQL from Python to the database. To do that, we need something that connects Python to MySQL. So we need to install the MySQL connector, which on the Learn page, that's in the database section. And it's right down here in getting started. I'll tidy this page up a little bit, but at the moment it's down here in getting started. And we basically just need to type this command, pip install MySQL connector Python, and that will install that. But again, we'll go through that in more detail. But if you're wanting to jump ahead, that's where you find this connector. So you'll recognize what we have here. We have, like before, we have these decorators. So we have the @ sign, and then the root, and this is just the root of the site. So it's just the main page, but this is the list books page, and we've got loan books and loan add. So just like before, each of these is a page. This is the library, remember? So, and down here you can remember we've got the render. So this is where we're rendering a page called booklist.html. So we did some stuff in Python, we'd render that page, the HTML will be all set up. So booklist looks like this. So it's going to say it's a book list, and we've got a for loop here, which lists through the books, and for each entry in book. So for book and book list, and then it creates a row in the table, and then for each entry in book, it creates an entry in the table. So we'll go through this more, but that's the logic of, you'll recognize that logic from working with lists. It's a for loop in Jinja, but it works the same way as a for loop in Python. So that's the magic in the background that's working to create our web page, but it's also using data that's come in from our Python. So if we go back to the app.py, we can see the data we've passed is called book list. So that's a list. But the key difference here is that this list has come from the database. And what you'll see here is, those of you who know some SQL will recognize that as SQL command, which sends a query to the database saying select all of the fields in the table. Sorry for people at home. Select everything. So star means select all of the columns from the table called books. So it's really simple. We'll go through the syntax of how to get this, but it sends that query off to the database and then gets that data back, and that's where book list comes from. So book list comes from, we use this fetch all connection.fetch all. It gets the data from the connector and puts it into a list called book list, and then we're back to what you're used to with working with lists in Python. So you can see how everything's starting to come together, and it's probably a little bit much to take in now, but as you work with it, you'll start to see how all the pieces fit together. So if I run this, which hopefully works, this is why I was a bit late, I was having trouble getting this to work, but let's see if it works. Yep, so it's running like before. We go over to our web page. And we've now got the Waikilikiri library website showing up. And if we go back to here, we'll see that when we're at the root of the website, so on the home page, we're rendering the page called base.html, which is here. So it's a simple page that says Waikilikiri library. Then it has some links called list books. Then it uses some built-in code from Jinja to using URL4, which we can look at a bit more, which is basically directing, it automatically creates the URL to list books, and same for loan book. And that's what we're seeing on this page, list book, loan book. And it's a static page, so we're not actually sending any data to that one. But if I click on list books, okay, it didn't work. But the idea is that if I click on list books, that should then call from the database, it renders that page and creates it. That's what we're working with here. And you can see in this one here, we've got a more complicated query. But again, it returns the data that we want and puts it into a list. And down here, we're starting to see that we can actually start interacting. We can use Python to interact with the query. So it doesn't just create static queries. You can write a for loop that creates a query for each value of each item in the list. So you could be looping through a list with IDs, and you could have a query that says select star from books where, and you can insert where ID equals, and you can insert the ID from your loop. So you're creating SQL queries using Python programs. So sorry that's not working. I'll have to get that worked out, but hopefully you get the idea of what we're doing. We're integrating web, Python, and database. That's why we're calling it a full stack framework. So we're pulling all those things together. Okay, so that's the background. But so what is a database anyway? So here we're going to introduce you to SQL, structured query language. So databases, let's just run some things just to get you started. It's a bit hard to fit on the screen because I've tried to make it bigger so you can see it, but here we have, if you're used to working with Excel or anything like that, you'll be familiar with this idea of a table. So we have some data with rows and some columns, sometimes called columns, sometimes called fields. So we have a table here called people. So we've given it a descriptive name. It's obviously got some information about people. And we've got an ID, a name, a city, sex or gender, age, and weight. So this is just an example table that we've got for you guys to play with. You probably have first name and last name and all that, but this is just an example of some data. And the first one is Christine. Her ID is 01091, lives in Christchurch, female, age 22, and 60.3 kilograms. So that's the kind of data that we have. And this up here, this is an example of an SQL query. And so it begins with select. So there are different kinds of queries. We'll start with select queries. Select is a query that just displays data. The other types are update, insert, and delete, which we'll get into. But for now, we'll be looking at just extracting data. That's where probably most data work happens, is just getting data out. But when you're writing code with programs, later on you need to start changing the data as well. So that's where you update and insert data. So when you log onto a website and say, create a new user or add a new user, to add that user, you have to add a row to the user table. So that's where you'd use an insert query. But for now, we're going to be using select. So select star is a shortcut for meaning give me all of these columns from, and comp636 is over here we've got a schema, which I'll come to, but and so often you'll just do it like this. So select star from people, and people is the name of this table. So this is the table called people, and select star. We run it here, and it gives us this data. It just gives us the whole table, which is which is kind of useful, but because we can actually put multiple queries together. But just remember the semicolon on the end. But what we can do with where it starts to get useful is, what if we only want to see the people who are from Christchurch? This is where we use the keyword where. This is one that you'll use a lot. Where is a condition. We can create some sort of condition and it'll limit the rows that are displayed. So let's just show the people from Christchurch. So city equals, and we can use, just like in Python, we can use single or double quotes. So now when we run this one, you can see that it's only showing the people who live in Christchurch. But we can also only look for the females living in Christchurch. So we can go and sex equals F. And if we want, then we can keep going. And age is greater than or equal to 20. So we can add all of those conditions and we can get, we can limit it down. If we're writing code in Python and we're looping around, we might be actually using the ID. So we could actually say ID equals 1003, and it'll just give us the one row. So I'll keep the old one here, and this is why we use the semicolon. You can copy another query down. I could say ID equals 1003 and run that one. And it just gives us the one. So we could have a database full of thousands of people, and rather than having to, in your code, you may have had to, instead of having to do a for loop that goes through all of the people looking for the one you're after, the database takes care of that for you. So you just have to go, your for loop knows what the ID is, and you just send the ID off in a query like this. Really simple query. The database takes care of all the searching. It does it. It's really good at it, really fast at it, and it returns you the information that your code can then work with. Okay. So that's one kind of query. We'll stick with this one here. If you're a data analyst, then writing queries, you can write big, long queries. But when you're designing a full stack web app and you're working between Python, you'll be using the features of both. So you might write quite simple queries that are combined with fancy stuff in Python, or you might write a more complicated query that makes it easier in Python. Often there's different ways of doing the same thing. You can sort. Remember we used Lambda functions to sort a list, or you can actually use SQL for sorting. So I'll show you how we do that. So I'll remove the where clause. Now, if you want to comment something in SQL, you just go 2 dashes, like 2 minus signs and a space. And so now if I run this one, it's ignoring that line. So I'll just keep it there so we can remember it. But if we want to sort something, then this is where we use order by. So I can say order by age. So now if I run the query, we'll see that it's sorting from the lowest age. If I add the word desk afterwards, that changes it to descending. So by default, it sorts ascending. So A, B, C, D, or 1, 2, 3, 4. If I sort descending, it's Z, Y, X, or 10, 9, 8, 7, 6. So it's that way. So if I run this one now, we can see that it's starting with the oldest person and sorting downwards. I can also mix it up, and I can order by age and weight descending. So now we've got all the people who are age 17, and we start from order of weight, from highest to lowest weight. And then we get to 18, and then it's highest to lowest. Or we can change the order if we want. Probably wouldn't be so meaningful with weight, but this is really useful too, because remember how complicated it got to sort things in Python, especially if you had different things and mixing the directions like this. It's one ascending, one descending, got quite complicated, but you can just do it like that in SQL. So that's where you can sort of use each technology to its strengths. So Python is really good at looping and logic. SQL is really good at sorting, filtering, and all that sort of thing. Okay, so that's listing data by constraining the data with conditions. So that's the where clause. And now we can sort it with order by. At the moment, we're just using star, select star from, but we don't always want to display every every field, especially when you're doing your Python. You may find that you're wanting to take the first in your list. You might want to be taking the first item in the list, and the second and third. If you write a query like this and someone adds a column into the table, that might mess up your list. So we can name the fields we want to show. So if you're presenting this on a login page, you're not going to want to see the ID. You're probably just wanting to see the name and the city. So we can go name, comma, city. So now when we run the query, we can see that it's just 2 columns. And if we can then add the where clause, and we can leave that if we want. So now it's just giving us the names of the people who are females over 20 from Christchurch. If you're doing maybe you're doing a marketing campaign, then you could find that. Or this could have been a query on your Python. On the web page, you might have chosen some options, and from a drop-down box or something, and then Python sends the Christchurch could be a variable that came from the web page. Python then understood, and then inserted into the SQL query as a string. And so this could have been chosen from a list, and the age could have been typed in. So this is how all this starts to connect. So a simple query like this could be quite useful. Okay, so what else do we have? Okay, so we've looked at order by. One other one that's useful is distinct. So if I go, so select distinct. When I run that, nothing changes. But what distinct does is let's get rid of that. And we choose, let's just change this to age and city. I'll get rid of distinct first. And actually I'll order by. Age and city. Okay, so we've got all these people who are 17, who are from Auckland, Christchurch, etc. But what distinct does, so we can see there's lots of repeats, right? So if I add distinct back in again, then it only returns one unique row. So so before we had